Picture a kid just standing in the middle of a super crowded, vibrant marketplace. You know the scene. Hundreds of faces rushing by, thousands of objects stacked up on tables. There's this massive explosion of colors and sounds and constant movement. Honestly, it's total chaos. And yet, within seconds, that child's eyes lock onto a familiar face. How does that happen? How do we take all that messy, unpredictable reality and just instantly find meaning? We do it so naturally that it honestly feels like magic. But what if we could break that magic down, like step by step into a staircase of logic? Throughout this explainer, we're going to trace exactly how a machine learns to see patterns in our world.
So really, how do you recognize your friend in a crowd? Or how do you know which song you truly like or which route is going to get you home the fastest? Just pause for a second. Think about that. What if human intelligence simply begins by noticing subtle differences? Because before artificial intelligence can predict anything, before it can recommend your next favorite movie, it has to learn how to notice. And to do that, it has to step onto the very first rung of our staircase.
All right, step 1. Reality becomes numbers. This is observation as data.
We hear the word data thrown around all the time, right? Usually like it's some glowing code in a mainframe. But data isn't magic. It is simply observation. It's a trace left by reality. Think about it. When you step on a scale, your weight becomes a number. When you check the weather, the temperature is a number. Think about your own daily habits, like how many action movies you watch or how many steps you take. We haven't changed the people. We're simply describing them using measurement. And this is the exact moment artificial intelligence begins. It's when human experience becomes numerical.
Which brings us to step 2. Numbers become locations. This is where we make a geometric shift. So once we have all these measurements, what do we actually do with them? Well, on one hand, you could just have a lifeless spreadsheet, endless rows and columns, kind of boring. But on the other side, we have points on a map. You see, machines don't read words the way you and I do, but they can navigate space. By taking raw numbers and treating them as coordinates, we completely shift the paradigm. We are literally turning information into geometry. Imagine 3 people. By using their height as a horizontal direction and their weight as a vertical direction, each person suddenly stops being a boring list of traits and literally becomes a dot on a grid, a specific point in space. And the crazy thing is, even if we added 100 other measurements like sleep habits or shopping choices and created a space with 100 dimensions, the math remains exactly the same. Every single experience just becomes a coordinate.
Moving right along to step 3, distance creates similarity, the birth of patterns.
Once our data becomes points floating in space, one really profound question follows. How do we know when 2 points are similar? Well, in information space, physical closeness is the exact measurement of similarity. What does similar mean to a machine? It literally means close. It's not an emotional feeling. It is a measurable geometric distance.
Let's ground this a bit. Imagine 2 users, and we're looking at their taste in movies. Because they both love action movies and both have pretty similar preferences for sci-fi, their coordinates place them right next to each other in this abstract taste space. The distance between them is incredibly small. So a machine doesn't need to know what a sci-fi movie actually is to know that these 2 people should probably get the exact same movie recommendation tonight.
Think about pouring sand onto a flat table. If it scatters evenly everywhere, there's no real shape. But if it gathers in certain areas, little hills form, right? As thousands of users are mapped out in our space, they naturally form dense crowds. And here's the kicker. The machine didn't invent these groups. No human had to go in and manually label them action lovers or romance lovers. The platform just measured the distance and the clusters naturally revealed themselves. Patterns are not created. They are discovered.
That takes us to step 4, the shape of meaning, moving through space.
Okay, so we have locations and we have clusters, but what if we want to represent something way more complex, like human taste? What if a preference had a direction? What if taste actually had a shape? What if meaning could point somewhere? Now, I know that sounds like poetry, but this is the literal mechanism that powers modern artificial intelligence.
We are no longer just looking at a static dot on a graph. We're actually looking at a path, a movement originating from the center, pointing outward. If you like action movies a ton and romance movies just a little bit, your path points strongly in one very specific direction. This trajectory takes multiple measurements and bundles them into one unified shape.
And guess what? That shape has a name, A vector. It's just an ordered list of numbers representing position and direction in space. Seriously, if you've ever felt intimidated by the math behind AI, let this be your breakthrough moment. A vector is simply a structured list of numbers that points toward meaning. Images become vectors, words become vectors. You, as a digital consumer, become a vector. AI is quite literally navigating through a universe of these arrows, constantly looking for which ones align.
Step 5, choosing what to measure. This is all about the power of features. Here's the thing. A machine absolutely cannot measure the whole universe. It's not infinitely wise. It only knows what we specifically tell it to look at. To a machine, an apartment is just its size, the number of bedrooms, and its distance to the subway. A car is its price, horsepower, and age. But how do you measure a dog? Well, you have to abstract it into dimensions, things like loyalty, bark volume, and walking needs. These choices, the things we decide to measure, are what we call features. A feature is basically just a measurable property. Think of it this way. If we build a fitness app and we don't include heart rate as a feature, the machine is completely blind to your cardiovascular health. Feature selection is where human choice lives. It's absolutely crucial. If we choose meaningful features, similar things cluster beautifully together. But if we choose poor features, the machine's understanding of the world becomes totally distorted. Features create understanding. And finally, step 6, predicting an uncertain world, using probability as confidence. Because let's face it, the real world isn't a perfect, neat mathematical grid. It's messy, it's super uncertain. So when you see an example like a jar of colored balls, don't think of it as some cold high school math problem. Think of it as the machine's confidence. When an AI looks at an image and says, "I see a cat," it isn't experiencing the fluffiness of the animal. It's looking at the density of patterns, it's measuring the distance in space, and it's calculating a likelihood. It's essentially saying, hey, based on where this vector points, I am 82% confident this belongs in the cat cluster. Probability is simply the machine expressing its confidence. So, bringing it all together, this is the predictive loop. It starts with observation. Reality becomes numbers. Those numbers then become locations in space, where distance measures similarity. Then, based on those natural clusters, the machine uses probabilities to measure likelihood and make a guess. And finally, the true learning happens. When the machine makes a mistake, the error actually corrects the prediction. The weights shift, the arrows realign. The machine gets smarter, not by magic, but by structured, incredibly beautiful mathematics. Which leaves us with one final, absolutely vital question. If AI is just a staircase of abstraction, going from measurement to coordinate, from vector to prediction, what happens when humans decide what machines are allowed to measure? The machine only sees the features we give it. It only learns from the data we collect. AI is not some autonomous wizard, it's a mirror reflecting the boundaries and the biases we choose to code into numbers. So the next time you use an AI tool, don't ask what the machine is thinking. Ask what it was allowed to measure. Until next time, keep questioning the patterns.